Hello students, so in the last video we have already seen the meson octave, and in this meson octave whatever particles we have seen, they have the parity minus and total angular momentum as 0, and it is represented by J is equal to 0 negative 0 minus. Okay, so now this meson octave has one more variation. Same meson octave can be reproduced for J is equal to 1 minus, that is total angular momentum is 1 and parity is minus. All the meson particle have the parity minus. So we will quickly draw the octave. So for the octave, you already know you need to draw octagon in this fashion. So this is octagon. Now you need to place the particles. So there will be 10 particles here as well. Okay, in the place of K there will be K star. Okay, representing J is equal to 1 now. So here also K star. Okay, now it is positive, this one is 0, this will be K bar star 0, this will be K bar minus and a star. Okay, in the place of pi meson we have rho. Okay, and rho will have rho minus, rho 0, okay, and rho plus, and the place of eta we have W meson, so W 0. Now similarly you need to draw horizontal lines, this horizontal line, this horizontal line, and this horizontal line. This all horizontal line is specifying you the strangeness. In the similar fashion, that will be S is equal to minus 1, S is equal to 0, then S is equal to plus 1. Okay, then you also have 3 diagonal lines as well, specifying you the charges. Okay, so there will be Q is equal to plus 1, Q is equal to 0, and this will be Q is equal to minus 1. Okay, and then for the isospin you have a vertical lines. I will represent it by another color. So this is the vertical line, this vertical line, this vertical line, vertical line, and this vertical line. So this all are showing me isospin, or you may call it as a third component of isospin. So third component of isospin goes in a fashion that the middle vertical line is given as a 0 third component of isospin, and then you increase by half to the right and decrease by half to the left. So it will be plus half here. Okay, then it will be plus 1. Similarly it will be minus half here, and here it will be minus 1. So these are all strangeness quantum number and third component of isospin. You can find all the properties of this mesons from this octave. Moreover, this is not the baryon, therefore baryon number is 0, and this is not a lepton also, that is why lepton number is 0. Okay, so this is your meson octave for J is equal to 1 minus, that is parity is negative and your total angular momentum is 1. Now moving further on, we will draw baryon octave. In the baryon octave you again will have octagon. we'll again have a 10 particles in this octagon. Particles will change, total angular momentum and parity will also change. Here total angular momentum and parity for this octave is half plus, that is total angular momentum is half. We already know this is an half integral spins, so total angular momentum is half and parity is positive. All the baryons are having parity positive and all the mesons are having parity negative. Please keep that in mind. We will require that in laws of conservation while finding out is it a strong interaction, weak interaction, or so on. Now fixing the particles. So first two particles are our nucleons, that will be neutron and proton. Then we have sigma minus, sigma naught and sigma plus here. Then we have cascade minus and cascade naught. Okay. Now in this particle, this last particle is lambda, capital lambda, okay, with zero charge. Now again you need to draw horizontal lines for the strangeness. Here the strangeness number is little bit in a different fashion. So you will start with 0 now and then you will decrease by 1. So it will be 0, minus 1 and minus 2. In the meson we have done 1, 0 and minus 1. So please focus there. Then we have charges. So charges is a diagonal. So this fashion. So here the charges will be q is equal to plus 1, here q will be 0 and here q will be minus 1. Now further down we will have a third component of isospin and that will be represented by the vertical lines. So here we have vertical lines. Okay, so this will give me the third component of isospin. So sigma minus will have isospin as minus 1, minus half, here it will be 0, here it will be plus half and here it will be 1. So these are the third component of isospin. So all the properties are known from here, that is total angular momentum is known, that is half. Parity is known, that is positive. Strangeness quantum number, that is 0, minus 1 and minus 2. 0 for the neutron and proton, minus 1 is for the sigma minus, sigma naught, sigma plus and lambda naught. Sigma that is strangeness minus 2 is for the cascade minus and cascade naught. Further down we also know all the third component of isospins for all the particles that is there in the baryons. Okay, on this baryons, since they are baryons, therefore baryon number will be 1 and they are not leptons, therefore lepton number will be 0. So all the quantum number, all the necessary quantum numbers are known from this diagram. Now one more variation for the baryons are baryon decuplet, and this baryon decuplet is decuplet. You need to have triangle. First you draw a triangle. This fashion. Then you will have a two horizontal line in this fashion. Now you will have 4 particles in the first horizontal line, then you will have 3 particles in second horizontal line, then you have 2 particles in second last and 1 particle in the last. Okay, so here place the particles now. So here you will have delta minus, here you will have delta naught, delta plus and delta double plus. Okay, similarly here you will have sigma minus, sigma naught, sigma plus. Here you will have cascade minus, cascade naught, and here you will have omega minus. Now please remember, since this baryon decuplet is for J is equal to 3 by 2 plus, that is total angular momentum is 3 by 2 and your parity is positive for all the particles. So here it is 3 by 2, so we give cascade and sigma a star, so that to distinguish between total angular momentums, both cascade and the cascade star have got different angular momentum as we have seen earlier. So these are the arrangements of the particles. Now we will find out the strangeness. So here it will be horizontal lines, there will be 4 horizontal lines in this fashion. So starting with s is equal to 0, then subtracting 1, s is equal to minus 1, s is equal to minus 2, then s is equal to minus 3. Remember, as there is a strangeness quantum number for omega is minus 3. Now let us draw the vertical lines for the third component of isospins. So this is first vertical line. For the second vertical line consists of only sigma. Third vertical line will be consisted of delta and cascade. Then fourth one will be sigma and omega. Fifth one will be again cascade and delta, then sigma alone. And then you have last delta. So here it will be in a similar fashion. You will start with 0 at the center and increase half to the right and the decrease half to the left. So it will be minus half, minus 1, minus 3 by 2. Similarly here it will be plus half, plus 1 and then plus 3 by 2. So this is pretty simple. If you have only 2 particles, you will have a minus 1 and plus 1 as their third component of isospin. If you are having 4 particles, then you will have a minus 3 by 2, minus half, plus half and then 3 by 2 as your third component of isospin. Okay, and for 3 particles that is minus 1, 0, 1, and for only 1 there will be 0. So this is Baryons decuplet, and of course you can find out already written on the particles. So this contains negative, 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 negative. So this horizontal line will be q negative, this horizontal line will be q0, q1, and this one will be q is equal to 2. Now this is it for the baryons, and this is a baryon because therefore baryon number is 1 and it is not a lepton, therefore lepton number is 0. Now considering this all 3, actually 4 diagrams we have done. So first one was Meson octet for j is equal to 0 negative, then it was Meson octave again, but j was equal to 1 minus. So k was replaced by k star and pi was replaced by rho and neta was replaced by w meson. And then we have baryon octave, and this baryon octave consists of angular momentum half and parity plus positive. So in this fashion it goes. Baryon number is 1 and lepton number is 0 for this baryons. And again we have baryon decuplet for j is equal to 3 by 2 plus. So here sigma is replaced by sigma star and cascade is replaced by cascade star. Other we have one more two new particles in this, that is delta and omega. And we all know we can find how we can find out the Steinius quantum number, third component of isospin. Already we will memorize this decuplet octave with the angular total angular momentum and the parity. So memorized. So now we will go further and see one more formula. There is one formula which states that the charge is equal to third component of isospin, that is I3, plus baryon number plus Steinius upon 2. This formula is very necessary in net set, okay, CSR and net, and as well as in set. In both the exams this formula based questions are asked. Okay, so this is called this is a charge, this is a isospin, third component of isospin, this is a Steinius quantum number, and this one is a baryon number. Okay, with the help of with the known Steinius, baryon number and third component of isospin, you can easily find out the charge, or other way around anyways. Okay, also one more part, this baryon number plus Steinius, baryon number plus Steinius is called as, this baryon number and Steinius is called as hypercharge, is called as hypercharge. This hypercharge is also asked in the exam many times, is called as hypercharge. Okay, baryon number and Steinius. For hypercharge of let's say we want to find out the nucleons, that is neutron and proton. So both are baryons, so B is 1, but they are not the strange particle, they have Steinius quantum number 0. So this will be the hypercharge for neutron, and proton will be just 1. Okay, you can easily figure it out here. See here, this neutron and this proton has a Steinius 0 and baryon number 1. So addition to that we will have 1. Also finding the charges is not that difficult. So for the third component of isospin, P has a third component of isospin as half and neutron has minus half. We will put that in the formula and let's find it out if this formula works. So for neutron, Q will be, third component of isospin was half, minus half plus half. So this was 1, this is 1 for both, so 1, and it will just cancel it out to be 0. So charge is 0, it worked. Okay, so similarly for proton, if you want to find out, so proton, the charge will be that plus half, third component of isospin was plus half and plus half again, then it will be plus 1. You can do it for any particle in this octave and decuplet. You will get this formula to be and get this formula verified, and remember this formula always. Okay, so Q is equal to I3 plus B plus S upon 2. So this formula is really necessary for net CSR net and set. Okay, and B plus S is called as hypercharge. This is also really necessary. Okay.